Alright, number 3, we want to place digits in a square so that we can make this number divisible by 4 and 8. Okay, so a number is divisible by 4 if the last 2 digits. So we're just kind of pick and choose and play with some numbers. So we're going to be making a single digit, something between 0 and 9. Okay, if I were to plug a 0 in there, I would have 6. 6 is not divisible by 4. Okay, so let's go with 16. Okay, 16 is divisible by 4. Okay, so 1 is a possibility. If we did 26, that one is not. 36 is. Okay, so it looks like since the digit 6 itself is not divisible by 4, we're needing one of these odd numbers. Looks like 1, 3, 5 is 76 divisible by 4. 4 goes into 7 once. 36 left over. Yes, 19. Okay, 1, 3, 7, 1, 3, 5, 7, and 9. Looks like these odd numbers will work for 4. 1, 3, 5, 7, 9. We also want this to be divisible by 8. So in order to be divisible by 8, we need the whole last 3 digits. So we're going to need 9 blank 6. So we're going to try something that's already divisible by 4. So let's try 9 16 divided by 8. Okay, 8 goes into 9 once, 1 left over with 11. 8 goes into 11 once with 3 left over, and 36. 8 will not go into 36 evenly. Okay, so it's not divisible by 9 16. Okay, what about 36? 8 goes into 9 once with 1 left over, so 13 goes into there once. 13 from 8 is 5, so 56. 8 times 7 is 56. Okay, so it looks like 9, 3, 6 will make that number divisible by 8 and 4. Now, what digit will make the number divisible by 8? Okay, so I thought it wanted both at the same time, so 3 as well. Is there a number that makes it divisible by 8 and not by 4? I didn't check all the other possibilities. Let's just try 3 and see if they want the same thing, because 3 works for both. Maybe they want something different. Okay, I thought that's what they wanted in the beginning. Okay. Okay, so part 4, we're going to fill in the blanks with the greatest digit that makes each statement true. So 3 divides 5, what? Okay, so we want to pick the biggest digit that makes it true. So the divisibility rule with 3 is if you add up all of these numbers, the sum has to be divisible by 3. So if we did 509, 5 plus 9 would give us 14. That's not divisible by 3. Okay, so we don't want 509. What if we did 508? That's the biggest number. The next biggest number, 5 plus 8, will give us 13. Okay, not divisible by 3. So if we do 507, 5 plus 7 will give us 12. Just skipping over 0, it doesn't add anything. 12 is divisible by 3. So we want to use a 7 in the first blank. Okay, so now 9 divides this number. Okay. So I want to get something that's divisible by 9. So I'm going to do it this way this time. It doesn't matter what position it's in. We're going to be adding up the digits. 7 plus 4 plus 2 plus 3. This gives us 11, 12, 13, 14, 15, 16. This gives us 16. Okay. So I want to add something to 16 so that it's divisible by 9. Okay. If we add 9, that will give us 25, which isn't divisible by 9. And then I would go down one at a time. So numbers that are divisible by 9 are, I'm just thinking out loud, 9 and then 18 and then 27. Okay, so I'm adding a single digit. I can't add 10 or 11 to get to 27. So the next largest number divisible by 9 is going to be 18. And to get from 16 to 18, I need 2. Okay, 2 will give me what we need. So we're going to put a 2 in the second position to get a number divisible by 9. Alright, so 11. This one is going to be a little bit more of a challenge. Okay, so 11 says you're going to add up the even place values and the odd place values and subtract them. Okay, so we have a 5. We need to fill this one in. We have a 2, and then we have a 1. Plugging in a single digit. This is 0, 1, 2, 3. So when we're talking about place values, these are even. I'm going to add up something plus 1. Don't know what that something is. I'm going to subtract 5 and 2. We'll add up those. Okay. And whatever I get, it needs to be divisible by 11. Okay. So since this is not going to be something bigger than 11, okay, because I can't add a single digit and a single digit and get a multiple of 11, these are the numbers that 11 will divide. 0, 11, 22, and any multiple of 11 after that. So we're looking to try to get 0. That's why I put the 0 here. If this is 7, I want this sum to be 7. So 5 plus 2 is 7. X plus 1 is 7. That would be a 6. So 6 is what we're going to need. 6 plus 1 is 7. 7 minus 7 is 0. And we can take 11 or 0 and divide by 11. Or say 11 divides 0. This is the way we write it. 11 divides 0. So we want a 6 here. D, we want it divisible by 5. Okay. So again, we want the biggest number, and it's divisible by 5 if the term ends in a 0 or 5. So 5 is going to be the bigger number here, so we're going to put a 5. We only have two choices, 5 or 0. And then E, we have E and F, two more parts. We want this divisible by 6. This number will be divisible by 6 if it's divisible by 2 and 3. Okay, so 6 we need 2 and 3. 2 we can see easily. The last digit ends in an even number. So now we just need the sum of the digits. 5 plus 5 plus 6. That's 16. Okay. I need a number that's divisible by 3. Okay. So I'm thinking again out loud. Multiples of 3. 3, 6, 9. I want something bigger. So let's go bigger than 16. It would be 18, 21, 24, 27. Okay, so in order to get to 27, we would have to add 11. So we can't make 27. We can make 24. From 16, we can get to 24 by adding an 8. Okay, so 8 needs to be the digit out front here. And then we want this one divisible by 8, biggest possible number. And we're looking at the last 3 digits. Okay, so we have 0, 8, 0. So basically we're looking for, I don't know why I put an 8 here. We're looking for I was just thinking that would be divisible. Looking for a 2-digit number that's divisible by 8, since this 0 is not going to play a role. 9 is not, 8 is, because 80 divided by 8 is 10. That's going to be the biggest digit we can use. So I was kind of jumping there before we talked it out, but 8 is what we need here.